Okay, so this is the video lesson for the start of Chapter 9, Section 9.1, Quadratic Graphs and Their Properties. So in Chapter 8, we learned how to multiply two binomials to get a trinomial, which most likely ended up as a quadratic polynomial, and then to factor them, to go backwards, to break it into two binomials. This section we're going to learn how to graph these polynomials. So a quadratic polynomial we learned in Chapter 8. Quadratic means 2 degrees, and polynomial just means more than one monomial, or more than one term. And so the degree 2, right, is the quadratic part. So these are all going to have, the highest term is going to be x squared. So a quadratic function is going to be a function of this form. So a quadratic polynomial that equals y. So you have an x and a y, so you can have points that will give you a graph. So they're going to be in standard form a x squared plus bx plus c, which we've talked about before when we were learning to factor. Obviously a does not equal 0. So here is our quadratic parent function. This is just the most standard of the quadratics. And this is x squared. And you can see this is a parabola where this point here is called the vertex and it's the minimum. And then there's an axis of symmetry. That means there's a line that you could take this parabola and pretend it was on a piece of paper, and you could fold it in half and they'd match up, right? So this side is symmetric to this side, and this is the line that you could fold it on to make it symmetric. So this is the line of symmetry. And that's going to be helpful in graphing these. Okay, and there's also, if it's upside down, then the vertex would be a maximum. Okay, so if it's a smile parabola, the bottom is the vertex is a minimum, and then if it's a frown parabola, the top is the vertex and it's a maximum. Okay, I think I left space here to define these terms, but you can look at them up in the book. We don't need to find them. Okay, moving on. Problem 1. So we're going to find the vertex and state whether it's a minimum or a maximum. So find the coordinates of the vertex, maximum or minimum. So let's start with A. We can see here the vertex. This is a frown. So this vertex is going to be a maximum, and it is at x is 0 and y is 3. Right? So 1, 2, 3. And this is a maximum. Okay. And then here we have a minimum. Here's the vertex here, and that is at x is 1 and y is -1. So that's my vertex, and it is a minimum. Okay, so try this one on your own. You might have to press pause to maybe write it down for your notes, and then check back for the solution. Okay, hopefully it was easy enough to see that it was a minimum, because it was a smiley face. It's going down. The vertex is at the bottom, and the vertex is at my x is -2, and then my y is -3. Okay, moving on to problem 2. We're going to graph these. So we're going to make a table of values, and then we're going to state what the domain and the range are. So for parabolas, we can use values around 0. So I like to just do -2, -1, 0, 1, and 2. Because of the line of symmetry, we really could just do a couple, and then we can use the line of symmetry to reflect. But here we'll just start this way. We'll just plot points and draw them. So 5 points is enough, usually, as long as one of them is near the vertex, to draw the parabola. We will get to a point where if you just have the vertex and one other point, you can use the axis of symmetry to make another point, and then you really only need 2 points. But we're going to start with 5. So in this case, y is 1/3 x squared. So we're going to take our x and multiply it, square it, and then multiply it by 1/2. In this case, this is 1/3 times 4. So that is 4/3. And then we'll plot that point, which is it's about 1.33. No, sorry. Yeah, 1 and 1/3. Okay, so then we'll go to -2. And 1 and 1/3, so that's going to be here. And I'm not really leaving a lot of room here. This point is going to be -2, 1 and 1/3. Okay, and then we'll do the same with -1. 1/3 times -1 squared is 1/3 times 1, which is just 1/3, which is about 0.333 repeating. So that's going to be -1 1/3 here. And then 0 is just going to be 1/3 times 0. 0 squared is 0, so this is just 0. So we have 0.00. And then at this point, we can, well, not yet. We'll talk about that later. Okay, let's plug in 1/3 times 1 squared is just 1/3 times 1, which is just 1/3. And you can see how I set this up, 1 and 1/3, right? Each of these is a third. And then, what color haven't I used? Blue. 1/3 times 2 squared is 1/3 times 4, which is 4/3, which is 1 1/3. So here, and so you can see if you connect the dots. Oops, that is not really connecting the dots. This is our graph. Okay, and you can see how eventually, right, we can see that we'll figure out what the axis of symmetry is, and then we can reflect them. Why don't you try this one on your own? Make a table here for x, maybe pick, I guess here I had you just pick these. I would do the same values we did before. Just do -2, -1, -2, -1, 0, 1, and 2. And if you want to throw in an extra 3 there, that'll give you 1 more point. Okay, so make your table with your x's. I said to use -2, -1, 0, 1, and 2. It may be 3. And then your y is -3x squared. And then you can do your points and then plot them and then connect them. And then check back for the solution. Press pause. Okay, here's the graph here. If you plugged in these values, you got -12, -3, -12, -3, 0, -3, -12. You plug in 3, you get -27. And you can see here that this is your axis of symmetry. Everything is symmetric there. So if you have to go from this point 3 to the left to get to the axis of symmetry, that means you have to go 3 more to the left to get the other point. So you can see how you can use that. And we'll be using that more. Just wanted to kind of show you how that would work. And then, so since you have this point, you can get this point without doing the math, and then you can connect the dots. So this is an upside down parabola. Okay, so we saw before we have the smile and the frown parabolas. The thing that is going to affect that or impact that is the coefficient on the x squared term, or your a. So this a here is where you can tell if it opens up like a smile or opens down like a frown. So if a is negative, then the parabola opens down, and we saw that here, right? My a here was -3, so it's down, it's a frown with a maximum. And then the a also affects the width. So you have to just look at the absolute value of a. So the negative or the positive sign, it just gives it up or down. But the magnitude or the absolute value of a is going to say if it's wider or more narrow. So here's your parent function where my a is just 1. So this is just our regular parabola right in the center. If a is 2, it gets skinnier or more narrow. So the higher the absolute value of a is, that means it makes it more narrow. And then the smaller it gets, the absolute value of a, so like fractions here, in this case 1/2, is wider. So if you think about 1 in the middle, if you go between 0 and 1, it gets wider. If you go above 1, it gets more narrow. So we'll use that fact here in problem 3 to order these 3 functions from the widest to the narrowest. And these graphs, they're actually graphed, so you can see them. In the homework, they won't be, so you can just actually use the numbers. So in this case, since we're just ordering widest to narrowest, we don't care about the sign. So you want to ignore that negative and just get the absolute value here. So this here is my absolute value of a is 4. And then this is absolute value of a is 1/4. And then this absolute value of a is 1, right? The invisible 1. And so since we're doing the widest, we're going to be taking our 3 absolute values and ordering them lowest to highest, right? So we're looking for, so that will be 1/4, 1, and then 4. And now it's asking for the functions listed from widest to narrowest. So then just take your number and then turn it back into the function, right? This was x squared, 1/4 was 1/4 x squared, so that's our widest. 1 was x squared, so that's our middle one, and then the 4 was actually negative 4x squared. So those are our three functions ordered from widest to narrowest. Okay, so just look at the absolute value of a, order from smallest to largest, and then rewrite them as a function. The one that corresponds with the right a that's listed. Okay, so try this for this red star here. And again, these ones aren't graphed here, so you can't actually see, and you can see in this picture, right, 1/4, that is the widest, then this one, and then this gets more narrow. And so even though it's upside down, we don't care about that. Okay, so figure out what your absolute value of a of all three of these are, order from smallest to largest, and then rewrite these functions, whichever correspond in the right order. All right, so press pause, do that, and then check back for your solution. All right, so hopefully you got, notice that this here, the absolute value here is the smallest at 1/3. So that was the smallest, so that is negative 1/3 x squared. That's going to be the widest one. And then this one had a 1 for its absolute value of a, so that was next, negative x squared. And then this one had a 3, so that's going to be the most narrow, and that's just 3x squared. And then just write them in order. Okay, so moving on. The y-axis is the axis of symmetry for graphs of the functions of this form. So if b is 0, so if there's no b term, it's just ax squared plus c. And the value of c actually moves or translates the graph up or down. So here if we have this parabola, parent function right down the center, x squared, and if you just add 3 to that, x squared plus 3, it just takes the whole graph and moves it up 3. X squared minus 2 would take that parent function and just move the graph down 2. So the c is going to just affect the movement of the parabola up or down, right? Where the a affects if it's upward facing or downward facing, and then if it's wide or narrow, the c is going to affect up or down, or the whole thing moving up or down, not reflected, not like down. Okay, so problem 4 says, how is the graph of 2x squared plus 3 different from the graph of 2x squared? Well, we can see here the difference is just that you add 3 to it, and then what we just learned above is that it just means it goes up 3. So it's different from the graph because it's that same graph moved up to 3. It's moved up 3. Okay, and I'm not going to graph that, but I'll have you guys graph. Actually, let's do this one together. I'm not going to make you do that, since we didn't do it that way in problem 4. So this says to graph both of these, and how are the graphs related? So we're going to do a table where we're going to have our x, and we're going to pick -2, -1, and 0. And then we're going to plug that into x squared, and then we're going to plug that into x squared minus 3. And then we're going to plot the two different points, and then we'll plot them at the same time. So let's look at this one. This is -2 squared. This is just 4. And then this is, right, this is the same as that. So it's 4 minus 3, which is 1. So we'll first graph -2, 4. That goes here. This is my -2, 4. And let's do this in red. 4 minus 3 equals 1. So this is going to be 2, 1. So we'll make this graph will be red, and this graph will be green. Okay, so let's do -1 squared. That's just 1. So in our green, we do -1, 1. And then 0 squared is just 0. So this one's going to be 0. All right, and then we can see here, this is our, since these are both of this form, ax squared plus c, in this case c is 0. And that means the axis of symmetry is the y-axis. So that means if this is 1 away from the axis of symmetry, then 1 more away is here. This is 2 away, so 1, 2 this way. So we don't actually have to do those other points. And then we can connect the dots there. So that's our x squared graph. And then this one, I wanted to answer this before we actually graphed it. What are we expecting this to do? Well, we have x squared here, and this is x squared minus 3. So the only thing that changed is we subtracted 3 after. So that means this is going to go down 3. It's going to take this graph and go down 3. So we should expect it to look write something like this. Okay, but let's still use the graph. So this one, this point at -1 is going to be 1 minus 3. So this is -2. So let's graph -1, -2 here. And then 0 minus 3 is going to be -3. So let's graph 0, -3. And I already did that because we knew that was what it's going to do. We have the same axis of symmetry. So since this is 1 away, this is also 1 away the other way. This is 1, 2, 1, 2 here. And then we can connect the dots. And so this is my x squared minus 3. So you can see it's basically like this graph. If you just take this green line right here, this green U or a parabola, and just move it down 3, you have x squared minus 3. Okay, and then it does ask how are they related. X squared minus 3 is just x squared moved down 3. Okay. That's it. Time for your practice on this. Enjoy.